You may have seen recent headlines claiming that a long-term ketogenic diet in mice led to fatty liver, diabetes, and reduced lifespan. If you did, you might wonder, does that mean ketogenic diets are dangerous for me or for people? Well, the short answer, despite the misleading headlines, is no. And here's why that mouse study is deeply flawed when it applies to humans. First, let's just review the study. So the authors fed genetically modified mice a 90% fat, 10% protein, essentially 0% carb diet over a long period, meaning long relative to the mouse lifespan. And they observed several negative outcomes with biochemical markers of organ stress in the liver and others, altered metabolite profiles, increased triglycerides, reduced survival in some groups, and signs of disrupted metabolism. So the study argues that sustained ketosis may carry hidden risks, especially when maintained continuously over a long duration. I would throw in, especially in mice. So those are alarming findings if you assume mice are the same as humans, and that assumption is where the trouble begins. Now, I understand the reason for using rodents and mice and rats. We can't realistically do 20 or 30-year human nutrition studies, but we can try to represent that with rodent studies. But there's a big assumption that a few months in rodents actually represents many decades in humans for all the health parameters we're measuring. That's a leap of faith that we have to accept if we're going to accept this data. But the metabolic stresses that manifest over months in a mouse may not translate to the human experience because humans have adaptive flexibility and redundancy, repair systems, lifespan buffers, and lots of other features. So I'm not ready to make that leap with the mice and the rats, are you? But there are other concerns too, such as the non-physiologic diet conditions. In the study, the mice were likely under constant rigid ketosis with a very high fat, low protein, essentially no carb diet. And that doesn't represent the ketogenic diet most humans eat. And on top of that, throw in the synthetic feed components and potential nutrient imbalances. And we have to wonder how this represents a real food, ad lib, keto diet that almost always results in a nutrient-dense diet with natural calorie reduction. But there's also the genetic homogeneity and lack of metabolic resilience. You see, lab mice are often inbred. They can be genetically uniform or even altered strains with peculiar vulnerabilities. So many lack the metabolic resilience or diversity seen in human populations. If a mouse strain has a marginal ability to handle high ketone production or lipid metabolism, that flaw might show up strongly in that one study. But it would not generalize to healthy humans with more flexible metabolism, or possibly even to other mice for that matter, right? So that's a big problem. And we also have to recognize that ketosis regulation differs between species. Humans regulate ketosis with hormonal feedback, insulin, glucagon, cortisol, and others like even thyroid or adiponectin. So in real life, we cycle in and out of mild or higher levels of ketosis based on the meals we eat, fasting, exercise, stress, sleep, so many others. Mice produce ketones differently with different rates, substrate utilization, and tissue responses. So simply put, mice aren't humans, right? Especially when it comes to ketosis. But perhaps even more importantly is that human evidence contradicts this mouse data. There's ample human clinical trial data supporting the safety and efficacy of ketogenic and low-carb diets in metabolic disease. For instance, in type 2 diabetes and insulin resistance, ketogenic diets consistently show reduced A1C, reduced insulin levels, and they can lead to medication discontinuation with disease remission. It's pretty dramatic. In fatty liver disease, studies show that the liver fat reductions and improved liver enzymes occur with carbohydrate restriction. And this one's key because the mouse studies showed the exact opposite with increased liver fat. So which are you going to believe? Again, I'm going to believe the humans. And similarly, mice saw an increase in triglycerides, which is routinely shown to decrease in human studies with ketogenic interventions. So these findings should be huge red flags for overgeneralizing the mouse results to humans. And let's not forget other demonstrated benefits of ketogenic theory, whether it's PCOS with metabolic and hormonal improvements, or how low-carb and keto diets equal or outperform low-fat diets for weight loss and metabolic improvements. And ketogenic diets can be medical treatments for epilepsy, psychiatric disorders, and many other metabolic conditions. So I guess the point is when human data shows benefit and mouse data shows risk, which do you think we should trust? So I'm siding with the human outcomes 100% of the time. We can potentially use the mouse study as a hypothesis generator, although be it kind of a weak one at that, but we cannot elevate it to a clear guide for human nutrition. So this 2025 ketone mouse paper is a warning about blind extrapolation, not a verdict on human keto diets. What we should do instead is this. One, we need to acknowledge mechanistic findings as potentially interesting, but not determinative for humans. And we should ask for, demand, or look for human clinical trials that measure real-world health outcomes. We need to, and we really need to avoid sensational headlines claiming keto kills you, or keto is dangerous, or causes liver disease, especially when they rely on rodent data that doesn't reflect human physiology. And last, we need to recognize that if human data contradicts the rodent signal, the human signal must take precedence. So the next time you see a headline warning about ketogenic diets based on a mouse study, ask this question: does this match human experience? Are there human trials showing the same or the opposite? So maybe that's a clue, but it's not going to be a guide. Let's base dietary guidance on humans eating real food, living their lives, not on mice living in cages, okay? If you found this helpful, please like and subscribe, and please leave us a comment. I'm curious to hear what you think about, rodent studies, mice studies, and if or how that relates to humans. So thank you for watching. I'm Dr. Bret Scher. We'll see you here next time at Metabolic Mind, a nonprofit initiative of Bazuki Group. Thank you for watching. If you want to see more, check out these recommended videos. Also, if you haven't already, don't forget to subscribe to our channel to stay up to date with our content and help us expand the movement. And if you want to sign up for our newsletter, access our resources, read the latest research, or check out the Think Smart framework, click here to visit our website. See you on the next video.